My talk is about the old idea of Dynabook from Xerox back in the 70s and from where Smalltalks was born. The idea was to create a new medium for representation of knowledge and communication. In fact, the group that LK led in Xerox was called Learning Research Group. Their intention was not to build just a programming language, but to improve the way we learn things. And that vision was sort of shadowed by the fact that Smalltalks was a very successful programming language, at least in its first times. This broader idea was, I'm not sure if to say forgotten, but left aside. Okay, it was not followed. Okay, so what are we talking about when we talk about knowledge, about growing about something? It means building in our mind models of some subject, of some reality. It is building a collection of concepts and relations between them and other graph-like structures inside our mind. That's what we have in our mind when we understand something. So, what does it mean to teach and learn? It means to try to replicate that kind of structures from the mind of the teacher to the mind of the student. That is teaching and that is learning. We want to build something that will exist in the mind of the person we are teaching something to. There is another rather different way of learning stuff, that is learning from ourselves. When we need to learn about something that no one can teach us, maybe because nobody knows about it, so it's new, it's research, or maybe just because we like to investigate the world and learn from it. Okay, so when no one is teaching us something but we are still learning it, we are building models of that reality by ourselves. So, what do we do with that knowledge? With the knowledge we have in our minds, we can do stuff. We do that all the time, of course. But we also want to represent that knowledge, to make it permanent, to be able to store it, to be able to give something to other people, to try to teach them in an indirect way. So we use different ways to represent knowledge. The oldest one, the first one that was developed was to write it down on paper. Okay. So what happens when we represent our knowledge on a piece of paper? We are not a piece of paper and ink cannot hold a model. Okay. It can only hold a description, and that description uses very limited media. It can only use words and maybe pictures. It is of course static, it will not change, so we cannot show information that changes all the time. We can only describe that change in words, so we are in the most limited media to express change. And it doesn't react to our queries, it always looks the same. No matter if we understand it or not, or we have new questions, or we want to expand that knowledge, it still looks the same. More recently, a new way to communicate knowledge is video, but still, video doesn't hold models, just descriptions. It is true that it can use more powerful media, so it may make stuff easier to understand and more entertaining, less boring. It can show dynamic stuff, it can show evolutionary change if done properly. Okay, so producing good quality educational video is not trivial. but it still doesn't react to our queries or our growth in the field. So, this is the idea that Alan Kay had like 45 years ago. It's the Dynabook. He wanted kids to be able to use Dynabooks to explore and learn about the world. A Dynabook can have not just descriptions of models, but models themselves, formal models or different types of models that are computable, that can be dynamic, that can show change, and that are interactive, that can react to our queries and are also open for extension improvement. Not much has done in the last 45 years to make this true, to make this a reality. I know of one example that in parts comes a bit close to this vision, and is the old Squid News electronic magazine from year 2000. Maybe some of you remember this. This was a magazine meant to be read with text, with illustrations, with animations, but also with interactive media and dynamic media. So it explained you stuff about something and then let you play with that alive. Okay, that's the kind of thing that is mostly missing in most modern productions. So if we expand this vision, trying to get closer to the original Dynabook vision, we could say that Dynabook is not just a tool for learning and teaching, like this. The closest of that inheritance is the toys and Scratch that are used for teaching and learning, but a Dynabook can also be an experimental laboratory for a serious researcher, not just for kids. It can also be a lab notebook where we record our experiments and the results and all the stuff. But more important than that, it can also be a new and valid publication format. Okay? We could build Dynabooks that have all the formalities of a regular research paper, and also show what the paper is talking about live inside the paper, including all the data that was used to produce it, and all the simulations or data analysis or processing or whatever that was done. This is close to recent movements in the scientific community called reproducible research and open science, that is people who say that all scientific research to be considered public not only needs to include an explanation of what the scientist did and what he liked out of his results, hiding what he didn't like, of course, but should also include all the results, all the experiments, all the data, in a way that any researcher can not only read the paper, but put it to run and test the theories with different approaches, with different tools for analyzing data or processing data, and with different data sets. So, a Dynabook for research can include computable models of scientific theories, not just descriptions, and the regular explanations and text with static and dynamic graphs and data explorers, and the actual experiments, because in many cases the experiments can be tests that can simply be run. Okay? So, the title of the talk was Dynabook as a tool for research and development. This is essentially what I want to say about research, but what about development? What we're doing besides being an explanation of phenomena and a capture of knowledge, is also our theories that are computable are software. So we can say that a computable model of a theory is a framework for working in that domain. So we can just use them to build real-world applications. There's not a separate step. We can integrate all these different tasks or objectives in our day-to-day work on our virtual laboratory. Therefore, we can also use our own applications and the data generated by our users or by the real world to improve our own theories. Okay? And if we do this, instead of getting back reports, we can get back new data sets to test our theory. That is much better because it will let us learn. Okay, so I've been working at Satellogic for the last 7 years, and my work there has essentially been to build knowledge in the form of computable theories about several satellite related areas of knowledge, including optics and sensors to capture image, stuff about the light we capture, the behavior of all the physical systems that take a part in this, including atmospheric effects, and also mathematical models for cartography and the 3D shape of the terrain of the Earth. Doing all this work, learning sometimes stuff that was only new to me because I hadn't worked in this field before, but also discovering a couple of new results that were nowhere in published bibliography. Building all this stuff also resulted in building the frameworks that let us build applications to process the image we capture. It's all the same stuff. Okay, so the framework, the code was done in a way. This is the intention of the programmer. This is how we design the software. When we design software, when we write software, we are saying something. If our intention is to build a theory and not a field, then we do that. Then we leave aside any accidental complexity and focus on the stuff we care about and try to build models that make sense to people. Then our software is also knowledge. Okay, so the open science community is suggesting as a main tool for doing this kind of ideas to use Python and Jupyter notebooks. And this is getting some adoption, but in Smalltalks we have several very important advantages over Python and its libraries and tools. And one of them is that in Python the code is not integrated. Okay? You have code that is a base system, there is libraries maintained by very different groups that evolve very slowly, and that your job as a solution developer is essentially to write mashups of library codes to use them. So while these libraries do have some models, those models don't grow with your knowledge, so they are not theories of the field you are studying. They are just given. And the common practice is to just produce mashups of codes that are ported to different libraries to solve specific problems. So maybe you have a solution to some problem, but your code is not a complete theory. Okay? You cannot grow the whole code base that you use to build your solution. And the mindset is different. It's solution-oriented and not knowledge-oriented. Besides, there are other perhaps minor problems, like Python has a rather complex syntax, and Smalltalk has essentially no syntax. The syntax of Smalltalk can be described in 5 minutes, and then it's all about modeling and not about fighting the language. The tool that people use is Jupyter Notebooks. Jupyter Notebooks is, I will tell you briefly, it's a web server that you run in your machine that codes a Python interpreter with the support libraries installed in your system, and that renders HTML for you to browse in your web browser. And in there you can create a sequence of boxes, where one box can be markdown text with formulas, another one can be a Python script, and another one can be the result of a Python script, for example, a graph computed by Python. You sort of have the elements, but with that kind of tools, you cannot produce something like a good book or book journal article. It's very limited in what you can do, and as it's using whatever Python you have installed, is not, you cannot guarantee that the results can be reproduced by anyone. You need to have a specific version of Python, version of each library, and the data sets are not part of this, they are not stored with this. So getting people to actually replicate the results done by other researchers, while not impossible, is not easy and not comfortable. Okay? So that's why I say that a Smalltalk Dynabook can do this in a much better way. So, what do we have to do with these ideas? We should start building a provision Dynabooks, and we should improve our Smalltalk systems to support Dynabooks. And one important thing is that Dynabooks should not require the reader to know about Smalltalk if the Dynabook is not about programming per se. If it's about some other field, then the reader should find it more comfortable to read than a regular article or book. And I believe that if enough people think this kind of thing, and we could get Dynabooks to become an established, accepted publication method, this could be a killer app for Smalltalk. Of course, there's a lot of things that would need to be done in tools, for example, digitally segmenting the artifacts to guarantee integrity and that kind of thing, and making artifacts that are multi-platform and that just run. Squid News could do that very well at its time, so it shows by existence that it can be done. So, that's it. Questions?
Sorry, maybe I'm missing something, but maybe I don't see the correct approach, right? But I don't understand why you said that there is nothing in the last 45 years that currently gives the idea of Dynabook.
Yes.
But I guess all the support of tables, and all the software that we have inside of there, and all the applications that we can mount there to make research or development, we can now put maybe tables, have the possibility to use other keyboards, so they are huge processors, so they have a lot of possibility to build apps inside of that and create something. So I don't catch.
It's not common practice. I mean, when people want to teach something, they still write a book. They still write an article. Just text and graphs. I mean, yeah, this goes very in the very same direction that you're working. I think that what you showed today is a step in this direction. You talked more about software development, and I'm talking more about knowledge in general, but it's the same problem and it should have the same solutions. And I'm sorry to tell you again, this is not common practice. I'm not presenting a new set of tools. I'm just saying that I did the best I could do with whatever was contemplated. And I'm asking for everybody here to help improving the tools and building this corpus of material for this tool to be real. Yes?
Would a source control repository can be a Dynabook? Source control repository?
Well, maybe it could, but if it is a source code repo that includes some documentation and some data sets and some Python code, then the behavior of that will depend a lot of how you run it on your machine. So it cannot guarantee that the results will be the same. And therefore, you cannot guarantee that if you make some modification to the data analysis or to the data sets and get slightly different results, those results are only because of your changes or because of something else that you don't know that would be different. And that is a problem, because then you cannot argue with the other results.
You say that other people with other computers will we get different results?
There is that risk if you don't have a tool that guarantees that that will not happen. And that is very important, to have that.
Okay, thanks.
Okay, thank you.